Objective of this example is to find the current in this circuit. This is the circuit. We need to find how much current that goes through it. So this is what we are looking for. And also we need to find the terminal voltage of this battery. The terminal voltage is the difference of potential between A and B. This battery has an EMF of 12 volt. This longest side is represented by plus. This short side is negative. This we call it an EMF. This one is the internal resistance of the battery. We are looking to find how much current passes through it. Then the difference of potential between A and B, which is the terminal voltage of the battery. And also we need to look for how much power dissipated in the internal resistance and the resistor R. Before we start, we need to talk about Kirchhoffs junction rule. Kirchhoffs has two rules. The first rule we call junction rule, and the second rule we call it voltage rule. For junction rule, it says for any junction in an electrical circuit, the sum of the current flowing into that junction equals to the sum of the current flowing out of that junction. What we mean by junction is a point at which two or more wires are connected together. Let's say I have this wire, second wire, 3, 4. It doesn't matter how many wires are connected to that junction. It has to be two or more wires. Now, let's say I have this current goes in, I1. This current I2, let's say, goes out. This current I3, let's say, is going in. And this current I4 goes out. Just an example. So what says the rule of junction? The sum of the current that goes in equals to the sum of the current that goes out. So do we see which one goes in, which one goes out? This one and this one are going in. This one and this one are going out. So what do? We sum. This, I call it I3. Let's give the name. This one I3. We said this one and this one are going in. We call them I1 plus I3. These ones, I2 and I4, are going out. Will be I2 plus I4. Kirchhoffs junction rule. For any junction in an electrical circuit, the sum of the current flowing into the junction equals to the sum of the current flowing out of that junction. This is what I mean. Sum of the current goes in equals to the sum of the current that goes out. Kirchhoffs' second law says the sum of the potential differences in enclosed loop is zero. That means the sigma of all these potential differences we have in this circuit is zero. To solve the current in this circuit, first we need to choose a loop. This is our direction of this loop. This direction, you can choose it clockwise, you can choose it counterclockwise. It doesn't affect your result. Then you need to look to the current. How to find the direction of the current? You look for your EMF. If you have just one EMF, it's easy to find the direction of the current. If you have multiple EMFs, then you look to the one that has a higher EMF is the one you will choose as the first direction of your current. So in this case, I have one EMF. This side with a longer line and is positive. This side is shorter with negative. Direction of the current is the direction of electric field. The electric field goes from higher potential to the lower potential. That means this is our direction of electric field. it will be the same direction as the current. The choice of the direction of your current, it doesn't affect your result. Just when you do the calculations, that means if the value you found is negative, the real direction of the current is in opposite direction you choose. Now let's choose this direction of the current, and this is our direction of the loop. Now then you look, if you have a resistor, any current that goes in that resistor and is in the same direction as your loop, the difference of potential in that resistor is negative. So let me repeat. You choose the loop direction and the direction of your current. If the direction of your current in the resistor, you see this current will be going in that direction for this resistor and is in the same direction as the loop, because the loop will be like that. This loop is the same thing. The direction of the loop is this. So if the direction of the loop, if the direction of the loop is in the same direction as the current, the difference of potential in the resistor is negative. That means in this case, I have negative VR. The same thing for other resistor. We have the direction of the current is in that direction, and the direction of the loop is in that direction. So it will be minus VR. Now you go back and look for the EMF. Once you go with your loop, what you do? Loop, you are going to cross this negative and then jump, you continue. Which side you cross the last? The side you cross at the last is the sign of your difference of potential. That means the last side, when I come here like that, in and out, across the last side is plus. So this EMF will be plus E. And the sum, because I made the complete loop, I started from here, this is VR, then I came back to the start, which is the last point is this E or EMF. The sum of the voltages or the potential differences in enclosed loop is 0. Now the objective is to find the current. So we know Ohm's law, the potential difference in this resistor will be just the current that passes through this resistor times its resistance, R. So this VR will be just R times R. And I keep my negative here. So negative. Now again, I have this difference of potential will be I times R plus E equals to 0. So what do we have here? If I move this term to the other side, it will be E equals I R plus IR. So what will be I times R, the internal resistance, plus the resistance of the external resistor. So the current I will be E over R plus R. So if we do the math, we say this 12 volt, R is 50 ohms plus 0.7 ohms. So the current I, we say the current I be 0.237 amps. So this is how we calculate the current in enclosed loop. Now let's find the terminal voltage of the battery. The terminals of the battery are A and B. Now the difference of potential between A and B is the same difference of potential in this resistor, because this resistor is connected to the same point, this one. So what does mean? The difference of potential between A and B will be just the difference of potential in this resistors VR, which is I times R. So in this case, the current I, we said, is 0.2367 amps times 50 ohms is 11.83 volt. This is the difference of potential between A and B, or between the terminals of the battery. Now let's find the power dissipated in the resistor and in the battery's internal resistance. So we said the power dissipated in this resistor R, it will be just R times I squared. So R, we said, is 50 ohms, and the current I, we said, is 0.23. It was 66. We just put 7 amps squared. This will be 2.8 watt. The watt is the unit of power. Sometimes you will see joule per second. So if you see joule per second, is the same thing as watt. This is the power dissipated in the resistor. For the internal resistance, the power dissipated in the internal resistance, we just internal resistance times the square of the current that passes through this internal resistance. Said internal resistance has 0.7 ohm and the current is 0.237 amp, will be 0.039 watt. Thank you.